this is the class with CHRS, teaches from time to time, and it starts with you barely know anything about radios and tries every day that we do it to add something to your knowledge. People learn how to do the basic rebuilding process on most of these radios. It requires you to replace some kinds of parts, and you learn how to do that, which is how to identify the parts, how to identify replacements, and how to solder them in. And then the student I'm going to be working with today wants to learn, having done the soldering, now wants to learn about how things really work and what it all means. And so we have this radio here, which is an instructional aid. It's a simple radio spread out like this with its circuit diagram, so you can measure points in it and see what it does.
I always like to watch the current.
And that's the point of this, is to get people who just like radios to where they can fix their own. This is the simple radio, which was a circuit that was made from the mid-30s through the end of the tubes, called an All-American 5. It's basically the simplest radio you can make with little work at all. And these were very popular. They sold millions of them, and they used this happens to use octal tubes. The later ones used miniature tubes, but the same circuit. And this is one of them spread out like this, built on top of its circuit diagram, so you can use it as a demonstrator and teaching device. Can you see the voltmeter?
Oh yeah.
So now power's on. We now have we now have just to sure about 100 volts peak plus. You can measure the voltage, and you can determine there's voltage on the plate of the output tube, which there should be. And you can look at the cathode current, which is how much voltage is through that resistor, about 5 volts, which is what it's supposed to be. Sure, do. That's fine with me. That's what this is for. You know, and there's no particular signal at the moment, so the ABC voltage is going to be low. Sorry, that's the ground. This is the side of the ABC voltage.
Could be, what was the other one? They were both capacitors, 3.01? Oh, typically, yes, they would be the line capacitors if your AC is coming in this.
There we go. So you can tune in the station.
This is typically a line capacitor. It's not going to be any of the art. It would be this guy. 4. That's one of these.
It's not very sensitive, but
I guess with all the components spread out as part of the display, it has an effect on
it's hard to get it to work right that way. Yeah. And I went through and aligned it as best I could, and I added a pattern capacitor in because this inductance was too large. It was even worse before that. It sort of worked at my house, and now it's not even sort of working very well.
It's probably in the environment here.
Could be a resistor, could be a cap. I'm sure it's this one. You want to float no RF circuitry in those 4 little blocks. They're just codes usually for power distribution or patch suppression.
But you can go through this and you can show what voltages are present in place and talk about why they're the way they are. You can, for example, you can look at the plate of this tube, which is connected to here, I think. That's 47 volts. And on the other side of this resistor here, it's 80 volts. Why is that? Well, it's because of the current that flows through the tube, and you can now calculate the current because it's that many volts through 500,000 ohms. There's not much current. And you can talk about all the rest of why this part is here and why that. This resistor and this capacitor there to filter hum out of the plate voltage for this tube. And so on. Probably, if this were wired correctly, it'd be more sensitive. I hadn't realized that mistake was in there. This must have been some kind of kit that you built yourself, because the wiring is kind of not real pretty, and it's got a lot of mistakes in it. Most of which I had fixed, but not that.
Yeah, but you're not basically this was built for display, not necessarily for performance.
Well, no, but I mean, it has to work well enough that you can tell it's working.
Yeah, working. Because obviously the spread of all the components, that has effect on performance.
Oh, it does. Yeah. What this is for, I don't know. Because this is now feeding, the 8 volts into the ABC. That's. I didn't proofread the schematic. I think it's got mistakes in it too.
Oh, really?
I think somebody wired this as a kit. You got this in the box, and then you wired it up.
Oh, so this guy never looked at this guy. And then they passed it off, and the next guy wired it up.
Kit, probably.
Yeah.
It's probably a kit. Somebody built it.
Yeah.
It looks sort of hand built.
You see that? That tube is.
There's high voltages.
Well, but on this.
Ooh.
400 and
Oh, you're talking the plate.
Oh.
Well, yeah, I have one over there where the crayon mark is 140.
I talked to you at the
Well, that's
Niles.
really good. But it's an isolated thing.
Very
So
well.
you want to
And
go.
I bought a radio
So
that had
we can turn this guy
Yeah,
on.
this is what we run them through. This is
And
we get these from Alibaba. They're
5
used in
pin
welders.
going
And
clockwise,
this is the
looking at the bottom.
this is the primary. This is the secondary, and usually the primary goes to the volume control. The secondary goes from the incoming audio. That's the last thing we'll do. So the first thing we're going to do, as I mentioned, we have this isolated variac. Variac meaning you can essentially treat the voltage like a volume control. Right. So make sure it's turned all the way down. Now here's kind of a little bit of a distinction here. So this is a floating chassis set. If this set had a power transformer, this is critical because if something's going to go haywire in the set, you don't want to short out the power transformer.
We always use a form of isolated power, which is not what is in your house. And the reason why is because it's just a layer of safety in case you're careless. You get help if you have something.
So anyway, what I do is, so that we can move the chassis around, so that it doesn't break off. I'm gonna I would say, temporarily take it off. It's either going to be open or it's going to be like, just to make it easier. Resistance in the other one. But any reading is good, except for open. I played with them now. We've got some soldering.
Old solder don't you get oxidized and stuff?
Yeah, that's one
New
thing.
solder flows over, it melts the rosin out of the
a lot
center,
of
heats
these
it up.
are
Let's see heat
often
transfer.
run into socket problems.
It happens occasionally.
50C5?
These
Yes.
little sets don't really get, there's nothing in them.
That's the 35W4. That's the rectifier. So if you want to, you go down the line and try measuring. Now you could shove it in here if you wanted to, but do it very carefully so you don't. This is fairly stiff stuff. Maybe just get it in there so you're.
First of all, what's the make? Silvertone. If you were around radios for a while, you would know that's Sears and Roebuck.
It's called a fairly good converter. Just to see if that was it.
I don't know, I always look for numbers. I'm not sure if that's the model number or serial number.
And what it does is mixes
That
with
can
the
be either, but that's a good catch.
and see what lovely tones it makes.
Don't worry about getting this perfect.
No,
just
that
make
it
it
won't
so that it
matter.
doesn't.
I remember once where you put a little switch on the back for the audio in, and I wasn't paying attention. I had it the other way, and I cut through about 8 wires. And I go, oh man! I had to splice all those things back together. But it worked. The radio worked fine. So we're just holding the antenna together. See these old wax guys? We usually always change them out. This one's probably all right because it's not wax, but they get leaky, and then they start passing a little current through them. And then everything goes bonkers, all the voltages go off on all the tubes. So.
And that doesn't really mean a lot. The two most important ones are these two right here.
There's a matter to go over.
This has got
Well, we'll put it in. Oh, I'll trace it down to show you right where it is in a minute.
You can clip your end off
That
here.
would give us 10A.
So that's nice and neat. So now we know that we've gotten one end of the old capacitor replaced. Let's come in and replace the other side.
What we do
So
is.
you see what I'm doing? I'm trying to prevent myself from losing my place.
Give me a smile. Thank you.
Let's do this before we open it up. Let's give it the first smoke test.
Yeah, because of the tip size.
From the utility, they're finding there's nailing 60-year-olds. Okay, so this thing has got some issues in here at minimum.
So, first thing is, I'm trying to find out whether you know what resistors and capacitors and things do.
Well,
Are you familiar with Ohm's law?
yeah.
Okay, so write down Ohm's law for me.
Okay.
Let's run through a couple of examples.
Let's see, I'm thinking it's sometimes depicted like
Doing right now is practicing soldering.
this.
Soldering and twisting wires.
It's just more of the same.
Is that right?
Yeah, but what's the equation?
Oh,
E equals what?
MC squared. No, that's the one.
that's right.
It's the wrong one. We don't want to deal with that kind of energy here. The neighbors would object.
Let's see.
It's because I was
What
trying
do
to get
you
it without,
got?
well, I was trying
See,
to
where
do it
you're
without
trying to hook it.
trying to put it in there, but I think that's just too
Short? Well, I've got longer caps.
So the resistance tends to oppose the flow of current, right?
Right.
Or limit the flow of current. So if that's true, you have a given voltage, which is E. And
Well, I could get an old
for a
round.
given current, you need, for more resistance, you need more E, right?
Right.
So,
I'm trying to tell you to consider it.
so for a given resistance, the more current flows, the more voltage you get, right?
Right.
That's E equals I times R. Yeah, E equals IR, that's right. So, that's what resistors do when you can cut. For example, for this tube, I can measure the V plus, I can measure the plate voltage, and I know what the series resistor is, and you can calculate what the current is by dividing the voltage by that resistance. And I'll tell you it ain't much, but it
Okay.
doesn't need to be. It works the way it is.
Okay. And I've done that, but it's been 40 years.
Yeah, but I'm just trying to give it. So
Yeah, no, that's
you know what
coming
a,
back.
you know what a capacitor does.
Let's see. Well, I know you use
Shortest,
one to
crudest
take.
statement.
You use it to take care of noise.
That you can do that too. Yes.
Yeah, that's my.
Well, no, but in a more basic way than that.
Yeah, much better. Stores it.
It does. Stores charge. If you,
Hold it way up like this. You're trying to mash it in.
what does the capacitor do with DC?
Put it up on the dial. Hold it up when you get push down.
No, that I don't know.
Be careful.
Nothing.
Nothing.
Capacitor. See this picture of a capacitor?
Yes.
That's exactly what they are. Two pieces of metal, or two are close to each other but insulated from each
Right.
other.
Right.
So no DC, right?
So there's a field.
There's an electric field between
Yeah.
them, but there's no direct current passes through there. Except to charge the capacitor. When you first connect it. And when you feed it AC, the one side wiggles and the other side tries to follow it, right? And how hard it tries to follow it depends, is proportional to the frequency of the AC and the value of the capacitor. The more capacitance, the more current flows through it.
Right.
But only for alternating current. And the higher the frequency, the more current flows.
And that's because what? The more,
that's what-
oh, because it's more active.
Well,
It happens more times.
if you, what a capacitance is the measure of, you store charge. And so you
Right.
store, I won't say a coulomb because it's a lot of charge, a microcoulomb on this plate. And if you raise the voltage, well, that means you store more charge, which means you have to draw the charge from someplace. So as you raise the voltage, and you lower it, it flows back out. So this way AC will pass and DC will not.
Okay.
And the higher the frequency, the more AC passes.
When you say DC won't pass,
You
won't do anything.
You have here,
what
exactly.
you're
You
telling
have here 50 volts here and 0 volts here, and that's the way it should be.
Okay.
But then when this wiggles up and down, that will too.
Yeah.
But it'll leave the DC behind and just carry the changing part, the part that's changing. The DC.
Okay. Okay.
If it passes, you're in trouble.
So would you use it in? So what kind of circuits would you
Well, here, for
use
example-
and
for
not
example-
use
Capacitor.
Capacitor.
Well, here, for example, here's the way tubes work is the output is the plate, and that's usually at some high voltage, 50, in this case, between 50 and 100 volts, but the grid wants to sit at ground or close to ground.
Right.
So you need something that'll block the DC part and let the signal, which is the AC, you can't hear DC, that's just a steady thing, right? But the wiggly part pass through.
Yeah.
And that's exactly what this does. It's at about 47 volts in this radio, and this is at 0. And this capacitor brings the AC, the signal part, through.
So what benefit is there? It's going to store some energy in that capacitor.
Well, the benefit is you can have AC pass and not DC, because if you connected this directly, that you get 50 volts on here, this tube would go nuts and wouldn't work right.
Okay.
So it's isolate thing. It's to isolate DC and pass alternating current. In some cases, you don't care about the DC, but mostly you do.
Okay.
Now, another application for those is this one, which is connected across the primary, the output transformer. What does that do? Well, the higher the frequency, the more AC current passes to this, right? Because that's what they do. So it rolls off the treble, the higher frequencies.
Rolls off the treble.
Yeah, the treble, the higher frequency sounds.
Okay, that's what. Okay, that's up.
It just turns down the treble. It's like turning the treble control down on your stereo.
Okay. Okay.
And this is built in to sort of match what the speaker does, sort of. Because if you don't, it'll sound kind of harsh and nasty. Because this is a more complicated story having to do with the way loudspeakers are and the way this crummy power amplifier works. But
is it just like when you say it sounds nasty, static?
no,
Kind of sounds or what?
hissy and sharp, and like you turn your treble all the way up on your stereo.
Oh, okay. Yeah.
Sibilance.
High tones.
Sibilance, you know.
Too much sibilance and everything is it won't be right. And there's some aesthetic theories about when you don't have any bass, you don't want much treble either to sort of balance things, and I don't think that's quite true. But it's what they did. All the technology in this.
No, I'm saying for like radio technology. This is the equivalent to the radio that we reworked
Yes,
a couple of months
it
ago.
was
right?
essentially.
Wasn't that American Five or
Yeah, it
something?
was.
Yeah.
It might be miniature tubes, which yours was.
Right.
This circuit was evolved, I think, by RCA in the mid-1930s and used with very few changes by everybody until tubes went away. Because it's the cheapest way. There's only about 30 parts in this radio,
Top of the volume control. is
counting the
right there.
tubes. And it works. It's not very good, but it works well enough to get local stations, you know, and you can hear music on it if you don't mind that you don't hear very much of the music, which most people didn't.
Okay.
So what is it? Truncated or just it's in just a narrower
Well, the
frequency
the
band?
frequency range, the frequency band is narrow because
No, that cap's too big.
that's determined by what's called the band.
There's a small
These are
capacitor they
see
put
this
across the
LC.
pot to roll off.
There's an inductor and there's a capacitor parallel. You know, if I hang a weight from a spring and you pull it, it goes up and down at a certain frequency.
Yeah.
This is exactly the same as what an LC does, except it's electrical instead of mechanical.
Okay.
It's a resonator. And by the way you make these transformers and all of this, you get a curve. It's a filter, right? But the way AM radio works is if your filter is, say, 10 kilohertz wide, when you detect it, you get 5 kilohertz worth of audio because you get a carrier plus and minus.
Because of the wave? Or
Because of the way modulation works. So the bandwidth of the radio is determined by these filters. And it's usually set pretty narrow because that way you get more stations and less interference. The result is you don't get much high frequencies, you don't get any low frequencies because it's got a crummy little speaker.
Well, stick this
And it's not a wonderful power amplifier either.
So you call this intermediate frequency inductor? Transformer.
Anything with two windings on it, you know what a transformer does.
Right. It's either
You know what it is?
step down
The
or
two
step
coils
up.
coupled to each other, but they aren't connected together.
Right.
which
And
is
I
why this is
understand
presently
induction is like
this is
magic.
presently plugged into an isolation transformer, because right there, that's ground. I added this in, and that's connected to one side of the line. So you don't want to work on this without the isolation transformer. You just never do.
Okay.
Because otherwise, you know, if you're on a wet concrete floor, you know, you touch this and you're gone, or you're jolted in a way, which is an unpleasant experience, even if it isn't fatal.
I've had the unpleasant.
Well, that's got all of
So
it.
Oh yeah,
not
no,
the
I've
fatal part.
been zapped a few times.
Well, I just,
Well, the champion of zaps a guy named John Staples who comes around here. Who
like a
was
double
not my
O.
age, but when he was like 16 or
He said
something,
double-
we were working on his
triple O,
transmitter with
triple five,
1,500 volts in it, and he defeated a safety interlock. He was in hospital for 2 weeks with burn like this down his arm.
Whoa, so it went
Current
right through
flow.
his heart.
okay, well, we can get
Didn't,
one.
he's lucky, it didn't stop his heart.
Yeah.
And so his only thing, but he works in megawatt systems for particle accelerators, but he's very careful on high voltages.
I bet he is. Got a wake up.
Get out of here, we gotta get out of here.
What would you use that for, and why have all these capacitors hanging off it?
Let's see. So what capacitors are hanging off it? Let's see.
Well,
there is,
this,
that's not a
this,
capacitor.
and that. This is in series with it, and this is in parallel. This is a complication. You don't need to
Okay,
pretend that's
I'll
a short
forget about
circuit.
that. Okay.
But just that's an L, and this is what, a C.
No, there's another vet
Yeah.
Remember what they do when they're together?
So this, I guess, is this going to have some kind of resistance? Is that the?
No, it's mostly inductance.
It's mainly.
Its function is
Okay.
all electronic components are imperfect, but the part of this that you want is the inductance.
Okay.
Yes, it has resistance as well.
Yeah. A certain amount, probably not much. It's good.
Right.
Copper wire,
Yeah.
silver, or whatever. You
Copper. Nobody pays for. Silver is only 5% more conductive than copper.
Is that right? Oh, okay. I know.
Somebody made for racing motorcycles in the late 40s, I think. AMC made a cylinder head that rather than aluminum was made out of silver to see if it was any. I mean, the problem is, of course, it's expensive enough.
Oh, sure.
I mean, it's a racing machine. Not
Yeah,
so
yeah,
You,
so-
you have to guard the machine. Somebody steals it, and it weighs more, and it didn't really make that enough difference to make the signal that is in this radio above the signal frequency. You can do it either way.
Okay. Above or below.
Yeah, so for example, if you tune this to a megahertz here, middle of the BC band, this will be running at 1.455 megahertz. So that's how you get from this frequency to that, and then you amplify this.
So that frequency is way different. And
Well,
the benefit
this
that
is
you get-
455 kilohertz, which is very commonly used. 455, 465.
because there's less interference or what?
No, because because if you do it any other way, you have a capacitor with a whole bunch of sections to it and tune them all. And that's, in fact, mid-20s radios are made like that. They'll have these things with 4 capacitors and they're chained to connect them all. Before somebody figured out you could put them all on the same track. It's amazing how long that invention took to happen.
So that's what this
It'd be just more like this one with more sections.
Okay.
Yeah, both on one shaft.
You go in there and there's like.
So you're saying there's 2 different ones here?
There are.
Stuff
Yeah.
can see them.
And for the longer ones, there might be 4.
MPEG recorders.
Well, if you made what's called a tuned radio frequency amplifier, which does not have a converter, it does everything at the signal frequency until they
It's
detect
supposed
it.
to be, it's got the
But
plumbing.
that doesn't work very well above broadcast band frequency. Up to 7 megahertz.
Yeah, you gotta have
It's
it.
hard to get enough gain. It's hard to manage. This way, if you convert it all, then you can have as much gain, and all the bandwidth control is in what the bandwidth of this coil. Of these, because the front end usually isn't tuned sharply enough to matter. And so, it's just much more convenient to do this.
So is this the actual antenna?
Yep.
Oh, is it a toroid or what do you
No,
call
it's
that?
just-
It's just a.
It's just a loop antenna.
Loop
But if you
antenna.
wind the loop antenna on a ferrite bar, it can be smaller.
That's what it
This
is.
still has a vacuum.
That might be ferrite material, but I don't know. Is it? It is ferrite material. Sure.
Okay.
You want as much.
Yeah.
You want the highest mu, highest,
Highest IQ,
Part of the loud.
higher.
the highest flux concentration.
That's
it's a 005,
You know,
and it goes from the
and
46
I guess you did mention when you have a coil going, you know, that's wrapped around a ferrite rod, that increases the overall inductance.
Yeah.
It's almost like adding more
Adds
coil
more
for
power
an
then.
air type.
Well, it concentrates the flux.
Yeah, it concentrates the flux.
You know, there's some
Yellow, purple, orange.
magnetic flux
thumb
flows
roll.
through free air. No, that just tells you which way it
We
goes.
need to
Yeah.
get a 005.
Got-
Could it
Through
be a
free air.
short, short
But
range?
if you put iron near it, or something related to
Or
iron,
what, you want one
you
like this
concentrate the
style
flux
or
by a
the-
factor of 50 or 100 or 200.
Okay.
And things get much smaller.
That's why.
And because you can then have fewer turns of copper, because the flux is concentrated, you get lower resistance.
Oh, sure.
Which means
What was
there's
wrong?
a
Bunch of crap?
feature of an inductor, especially inductors, called Q. And that's the percent.
Okay. That's why they use the same units. Like ohms.
Yep, it's ohms. It's ohms.
Okay.
But the question is, with a resistor, you know what I mean by phase?
Not exactly.
That one already, you want the tubular type.
I think the tubular because it's got a.
So here's two signals. My imperfect drawing. And that's signal one. I think another signal that does just the same thing. Sorry, listen. If I make another signal that's just like,
Those are in phase.
that's just like that, those are in phase.
Yes.
If I make the other signal do this, that's the opposite, right?
Yes.
See that? That's out of phase by. So if you take the whole cycle of going from here and coming back to there again is 360 degrees. So this is 180 degrees out of phase. It's the opposite.
Okay. And but it looks like the amplitude's the same and the wavelengths. are
Like
about the
it could
same.
be, yeah.
I mean, it looks
this is
about
all
close-
conceptual stuff.
closely.
Yeah, it's not.
They're similar, but that's not what phase is about.
Phase
what you're telling me.
phase
It's
about
in-
is the relative timing.
Yeah.
This originally looked like this, and it turns out it's wax about 1/8 of an inch on each end, and then I stripped the outer cardboard shell out, and this is what's inside. So this is the foil. You know, that, like I said, they'd do foil this way, and this is one. So this is one foil group, and this is the other, and we can now. You want to see that? This was a 10th mic, probably 200-volt capacitor.
Okay.
And again, one end, and you can see where some of the wax is left on that end. And not so much on this end, because I stripped this more thoroughly. And let's see if I can unwrap this paper or not. I'm sure I can. I think I'm going to have to cut to start it.
Yeah, those dollies, I've seen those wheel dollies. Yeah, friends of mine do that. You'd be able to move your cars around at will, just pushing them on the ground. When you have a lot of cars and not a lot of space, it works.
There we go. So,
Here we go.
Oh, yeah, right. Yeah.
There's the wax.
there's wax, and now I start on this, and there's aluminum on that side, and aluminum here, and the paper is the insulator between them. See how that goes?
Yes, I do.
Only, you know, the moisture's gotten in here and in here. It probably didn't short through the paper, though I don't know about that for sure.
Yeah, that's great.
So that's what it does. Now, there were some capacitors made in the transition, they're all plastic dielectric now, and those don't get leaky. Well, the plastic, the moisture doesn't soak into them. They're, in the first place, they're not so, they're all sealed in plastic. It's a solid lump. And it's a better seal. The wires around break the seal at the end. The result is the experience, plastic capacitors are always good even if they're 30 years old.
So how many feet is there?
No, quite a few. It's
Yeah,
quite,
it sure
this is quite a bit of
Rolled up like
capacitance in
tape,
here.
Yeah.
It's peeling almost. It's only part of it now, but
Is it chocolate or caramel?
it's got Fairhead sauce on it.
Bee, it's a honeybee flavor.
It's got Fairhead sauce on it. Well, now, if I want to peel that anymore, I probably have to do a fresh cut. But you see how it goes, right?
Mm-hmm. You bet.
This is what they're made of.
Yeah.
Paper and tin foil. You see the tin foil to one side here and to the other side here. So you can group them at the ends here. That's what's in there.
Attaching the leads, how does that work?
What?
Attaching the leads.
It's probably, if it's tin, they probably just soldered them. They group them together, and it's probably soldered down there someplace. I didn't look.
So is one soldered on like the outside?
Well, no, one layer sticks over this end and crump. The other end
That's
sticks.
it. Yeah. Okay, that's it. Yeah.
So that's how it's done, and it's probably soldered. I can dig in here and see if I can see.
Yeah, you want 4,000 feet of fair.
The 5th floor and the 16th floor are particularly
on the website that they can find. When I joined, it was like, what classes do you want to do?
Yeah. Usually there's a hash mark. Yeah, it could be either one of these showing. I think it's his line. See that?
A little bit dirty.